So what if the biggest bottleneck stopping the AI revolution, isn't a lack of microchips or power grid failures or even running out of water to cool all these data centers? What if the real friction slowing everything down is just this massive, invisible lack of translation?
Yeah, it really it completely flips the script on how we measure technological progress because you start looking past the hardware and you realize the most critical vulnerabilities are hidden in really mundane things like employee handbooks or municipal zoning laws or even just customer service desks.
Right. Well, welcome to the Deep Dive, everyone. Today, we're looking at a pretty fascinating stack of analytical reports and theoretical frameworks tracking the global rollout of artificial intelligence.
Yeah, specifically the MGF weekly report and the residual analysis.
Exactly. And our mission here is really to explore this sudden, massive shift in where this technology is actually colliding with reality. We're going to get into things like the NAO systems model, the concept of system exhaustion, and even a radical rethinking of what actually makes a society stable.
But, and I think we need to be clear right up front, we aren't here to hype up AI's magical capabilities today.
No, definitely not.
And we aren't going down some, dystopian rabbit hole either. The focus today is purely structural.
Right. Purely looking at the data.
Exactly. We really want to look at the interfaces, like the actual tangible membranes where this high-speed technology makes contact with our relatively slow-moving human institutions. Because when you strip away the daily news cycle, a very clear, very surprising pattern emerges.
Yeah, and that pattern really jumped out at me in that document called the residual analysis. It basically tracks the constraints on AI deployment week by week, and it highlights this incredible contrast between two consecutive periods, week 23 and week 24.
Right.
So let's look at week 23 first. At that point, the primary bottlenecks were just entirely physical. I mean, the friction was basically a story of resource scarcity, right?
Yeah, totally. It was a physics problem.
Yeah, exactly. AI was colliding with reality in the form of massive electricity demands, literal gallons of water needed to cool the servers,
Yeah.
power grids just straining under the load, and of course, the global panic over semiconductor shortages.
Right. I mean, the entire conversation and really the flow of capital was just dedicated to fueling the machine. How do we generate enough power? How do we manufacture enough silicon? Those are, tangible, measurable roadblocks.
But then, just 1 week later, in the data week 24, those physical constraints are no longer the primary roadblocks.
Yeah, it's a massive pivot.
The friction shifted so dramatically. The report showed that suddenly the dominant bottlenecks were things categorized as undefined responsibility, contract design, corporate governance, and institutional translation.
Right.
It seems like the moment the technology actually starts running, the physics problem just vanishes, and a totally different kind of wall appears. Okay, let's unpack this. It's kind of like building a high-speed train network.
Okay, I like that.
In week 23, everyone was panicking about laying the steel tracks and generating enough electricity. But at week 24, the trains are running, and suddenly everyone realizes they forgot to build the ticketing stations, or define who is actually driving, or figure out who pays for the maintenance.
Yeah, that's a perfect analogy because the bottleneck is no longer about how we fuel the AI, it's about how we ground it in society.
Right.
The reports actually refer to this as the shift from physical infrastructure to institutional infrastructure. Like, think about a local hospital purchasing a highly advanced diagnostic AI.
Okay.
In week 23 terms, the concern was just, whether the hospital had the server space or the broadband to run it. But in week 24 terms, the hospital realizes they have absolutely no legal framework for what happens if the AI suggests a treatment that a human doctor disagrees with.
Oh, wow. Yeah, who holds the liability there?
Exactly, who is liable? Or even practically, how do you document an algorithm's decision in a medical chart that was designed for human notes?
So the system halts not because of a power outage, but because of a contract dispute.
Precisely. The technology is exposing the connection points of our society. The friction we are seeing now is basically the realization of undefined responsibility. You've got the hospital, the tech vendor, and the insurance company all staring at each other, trying to figure out who is, legally and operationally responsible for the space between the machine's output and the patient's reality.
Right, and to explain the mechanism behind why this is happening so abruptly, the MGF report outlines this three-layer observation model. They call it the NIOS model. Walk us through how these layers interact, because this really clarifies why the friction feels so intense right now.
Sure. So To understand the friction, we have to map out the different speeds at which our world operates. The model divides society into three layers. At
Okay.
the top is the narrative layer, the N. This is what we say, the public discourse, the media headlines, the marketing slogans, and this moves very quickly.
Right, the story changes every day.
Exactly. Then, below that is the intention or value layer, the I. This is what we actually expect or desire. It contains our historical ideologies, our deeply held concepts of fairness, justice, and human dignity.
And I imagine that one moves a lot slower.
Incredibly slowly. It takes generations to really shift societal values.
So we have the fast-moving story we tell ourselves on top, and the slow-moving values we actually hold underneath.
Yes. And then underneath both of those is the OS layer, the operational system. These are the engines actually driving reality. We're talking algorithms, global capital markets, supply chains, automated military infrastructure.
Right.
The OS layer is currently moving at breakneck speed. It is hyper-efficient, highly optimized, and crucially, largely indifferent to human narratives or value.
Which creates a massive velocity mismatch. I think the report uses the term shear like tectonic plates just grinding against each other.
Yes, that's exactly the word they use.
So the AI operational system is accelerating, but our legal structures, employment practices, and cultural expectations are still just crawling along at the pace of the intention layer.
And that shear is the source of the week 24 friction. When an AI system operates perfectly according to its internal logic, say, uh, optimizing a company's hiring pipeline to be flawlessly efficient, it is operating at the OS layer.
Okay, makes sense.
But when that same system automatically filters out candidates in a way that feels unfair to the public, it crashes headfirst into the intention layer. The machine is perfectly rational, but it creates what the reports term an OS compatibility error.
Here's where it gets really interesting to me. I want to push on that compatibility error concept for a moment. We keep hearing this phrase, undefined responsibility, popping up as the primary roadblock.
Yeah.
But is the AI actually creating brand new, unprecedented work for us to do? Or is this just previously hidden, everyday human coordination work that's suddenly glaringly obvious because the machine is moving too fast for us to cover it up?
What's fascinating here is it is almost entirely the latter. When humans collaborate, we naturally, almost invisibly, smooth over those gaps.
Right.
Like if you ask a coworker to compile a report and your instructions are slightly vague, the coworker reads the room, understands your general intent, makes a few judgment calls, and just delivers what you need. That is human coordination. It's translation work.
Yeah, we act as the glue between the rigid rules of a workplace and the messy reality of getting things done. We translate the raw output into a socially acceptable reality.
Yes, but an AI system doesn't have that innate human glue. It generates raw output at blistering speed. So all of that invisible translation work, clarifying intent, adjusting for social expectations, checking for ethical boundaries, it's suddenly ripped away.
Wow.
The raw, undefined edges of our institutions are just exposed. This means the sheer speed of the AI is actually generating an enormous backlog of translation work for the humans who are left in the loop.
Which totally explains why capital markets are suddenly pivoting. Because the reports mention that investment isn't just flowing into microchips anymore. Capital is being repositioned to secure this translation infrastructure.
Exactly. Investors are waking up.
They're realizing that if a local government cannot legally integrate a model, or a consumer just doesn't trust the interface, the smartest AI in the world basically becomes a stranded asset.
Right. It's useless.
So they are rushing to buy up governance, compliance, and legal tools to serve as, like, shock absorbers for this tectonic shear.
Because without that translation layer, deployment just stalls. The technology hits the wall of human values and simply bounces off.
Well, this brings us to a really sobering section of the documents.
Yeah.
We've established this massive grinding friction between the fast OS layer and our slow institutional values.
Yeah.
And the analytical frameworks here, specifically a measurement model called MCP v1.1, they explore what happens when a system is subjected to this kind of shear over a long period. And it introduces this phase called chronic depolarization.
Right. And the common assumption is that if society can't handle a technological shock, we will see a spectacular collapse, like a dramatic breaking point.
Yeah, the classic sci-fi disaster.
Exactly. But the MCP model suggests a much more insidious trajectory. If the translation layer isn't built to absorb the friction, society doesn't just shatter overnight. It enters a state of persistent, grinding exhaustion.
And the document breaks this down into two theoretical variables, right?
Right.
It's a system operating under high, constant tension combined with extremely low recovery capacity.
Let's visualize that mechanism. Imagine a workforce that is constantly forced to adapt to high-speed AI outputs. They are doing the exhausting, invisible work of translating these algorithmic decisions into human terms for their clients day in and day out.
So they are experiencing high friction.
Right, and if they don't have the time, the budget, or even just the cognitive space to rest and reset, meaning they have low recovery capacity, the system becomes hypersensitive.
The model calls it fatigue fixation and hypersensitivity to minor stimuli, which honestly, I think anyone who has worked in an understaffed office or lived through a period of intense sleep deprivation knows exactly how this mechanism works.
Oh, definitely.
When your recovery capacity is zero, a dropped coffee mug isn't just a minor annoyance, right? It feels like an insurmountable crisis. The system just loses all its shock absorption.
And this is where the theoretical framework offers a really profound redefinition of a very common word. The text completely redefines the concept of care.
Yes, this was the biggest aha moment in the entire stack for me. Because we usually think of care as an emotion, right? Empathy, compassion, feeling bad for someone. But this model treats it as cold, hard engineering.
Under this framework, care is absolutely not an emotion, it is an operational mechanism. They define it as a literal repolarization infrastructure.
Okay, explain how that works in practice. What does a repolarization infrastructure actually look like?
Think of a battery. When it discharges energy to perform work, it depolarizes. It needs to be plugged in to repolarize and recover its potential energy.
Okay, tracking.
In societal terms, care is the required operational maintenance to keep an organization, a legal system, or an individual from permanently burning out. It is the financial buffer a company maintains so its employees aren't working 80-hour weeks.
Okay.
It's the paid downtime. It is the cognitive surplus required to calmly evaluate an AI's mistake rather than panicking. If you design a system that optimizes purely for speed and strips away all the inefficiencies of downtime, you are eliminating the repolarization infrastructure. You are eliminating care.
And without that care infrastructure, the system slowly degrades into that chronic depolarization phase. It just grinds itself to dust. So what did this all mean for you, the listener?
That's the real question.
The reports point out specific silence areas in the economic data. Billions are flowing into foundational models, but you don't see that money flowing into local city councils or small retail businesses or everyday consumer households.
Which is a massive structural vulnerability, because those are the exact places where the heavy lifting of translation actually has to happen.
Right. A local health clinic has to figure out how to integrate an automated scheduling system without alienating their elderly patients who, just want to speak to a human.
Yeah.
The tech company built the software, but the clinic's front desk staff are the ones providing the repolarization infrastructure. They're acting as the human shock absorbers, calming down confused patients, translating the rigid algorithm into human empathy. And they are doing it without any extra budget or cognitive surplus.
And that is the core of the vulnerability. The stability of our current era isn't measured by how fast the AI can process data. According to these frameworks, stability is measured entirely by the recovery rate of those local organizations and individuals.
Wow.
If the front desk staff burn out, if the local municipality runs out of budget trying to regulate automated permits, the translation layer fails. The technology is essentially grounded.
Well, if that's the risk, that hyper-efficient systems will just exhaust us into chronic depolarization, it brings up a really crucial question about what we are actually trying to achieve here.
Absolutely.
Because the later documents in our stack, LMOS version 2.0, introduce a concept called fluid stability. And reading through it, I found myself genuinely confused for a moment.
Oh, how so?
Well, wait, isn't the whole marketing pitch for AI about eliminating friction? We're told the goal is to remove noise, streamline supply chains, perfectly synchronize our calendars, and just achieve total, flawless efficiency.
Right, the utopian vision.
But these models argue that perfect synchronization is actually a path to collapse. They claim that fluctuation and play are the true sources of stability. Why would we intentionally want inefficiency in our systems?
If we connect this to the bigger picture, it really requires a shift in how we view complex systems. A perfectly synchronized system, where every part moves in exact, frictionless lockstep, that is highly efficient in a static environment. But the real world is entirely unpredictable. So the models introduce the fluctuation axiom. It states that a hyper-efficient, synchronized system inevitably becomes rigid. It has absolutely no slack.
No room for error.
Right. So when a rigid system encounters an unexpected shock, say a sudden change in consumer behavior or a global supply chain disruption, it cannot bend. it shatters.
Oh, it's like a highly tuned sports car. It runs flawlessly on a perfectly smooth track, but the second it hits a pothole on a dit road, the suspension just snaps.
That's a great way to look at it. To survive the pothole, you need play in the steering. You need suspension that allows for independent movement. In a society, that play looks like friction. It
Interesting.
looks like localized differences, minor inefficiencies, debates in a town hall, or, the time it takes for a judge to weigh a complex legal argument. These aren't bugs to be eliminated. They are vital shock absorbers.
So true stability isn't a fixed frozen state of perfection. It's fluid stability, like the ability of a society to maintain multiple overlapping states, to absorb a shock, wobble a bit, and find a new equilibrium without breaking apart.
Exactly. The text warns that defining societal health as zero friction is a catastrophic mistake. Health is the ability to maintain fluctuation. And this actually leads to perhaps the most urgent warning in the entire stack, which is the danger of the closure gradient.
The pressure to close off meaning. The mechanism here is fascinating. Walk us through how AI speed specifically interacts with human cognition to create this danger.
Well, AI systems generate outputs like explanations, categorizations, summaries at a speed that far outpaces human biology. An AI can analyze a massive data set and output a definitive, confident answer in 2 seconds.
Right.
It categorizes a complex social issue into a strict binary, true or false, safe or unsafe, qualified or unqualified. But human cognition operates very differently. We require what the text calls cognitive cooling.
Meaning the time required to actually digest information.
Yes. When a complex issue arises, humans need space to process, to doubt, to discuss, and to reconsider. The closure gradient occurs when the speed of the machine's explanation forces society to accept a fixed meaning before we've had the cognitive cooling time to actually digest it.
Because the explanation arrives instantly, the system pressures us to act on it instantly. We lose the space to say, well, it's complicated, or let's look at the nuance.
Precisely. The technology forces rigid categorizations onto society faster than we can adapt. The danger isn't that the AI will stop working. The danger is that the AI works so fast that it destroys our phase fluidity.
We get locked in.
Yeah, we are pushed into rigid camps, forced to accept fixed meanings, and stripped of our ability to sit with ambiguity or maintain an open loop of inquiry.
We're forced to accept the final answer before we've even agreed on the parameters of the question. And tying this back to the battery metaphor, that constant pressure destroys our recovery capacity. If everything is instantly finalized and rigid, we just can't adapt.
And that is precisely why the LMOS framework proposes the necessity of a low-speed observation OS. It isn't a call to destroy the technology, not at all, but a structural necessity to push back against the pressure of high-speed synchronization.
Okay.
The goal of this low-speed framework isn't to generate rapid answers, but to artificially maintain reobservability.
To intentionally keep the loop open, to force the system to pause so the human translation layer has time to catch up, do the necessary operational care, and basically figure out how this new output actually aligns with our slow-moving institutional values.
Which brings us full circle to the data from week 23 and week 24. We solved, or at least we are solving, the physics problems. We know how to build the data centers. But we're only just beginning to confront the massive, invisible friction of societal integration.
Yeah, the bottleneck isn't the microchip, it's the translation infrastructure. The defining challenge of this era is managing the shear between a hyper-fast OS layer and the slow, necessary friction of human values. Because the interfaces, the membranes where the technology meets the hospital clerk, the local regulator, the small business owner, that is where the real weight of this transformation is being carried.
And I think that invites a very practical reflection. We've spent a lot of time analyzing the macro structures and the institutional exhaustion in the data, but these systems are made of individuals.
Right. So if the real friction of the future lies in undefined responsibility and the need for fluid stability, take a look at your own daily routines. As these high-speed algorithms integrate into your workflow, your tools, and your community, ask yourself, where are you secretly acting as the human shock absorber? Where are you providing the unacknowledged, uncompensated translation work, just trying to bridge the gap and make the technology fit into the messy reality of the human world?
Because the data suggests that bridging that gap is actually the most critical work currently keeping the system stable.
Absolutely. Well, thanks for joining us on this deep dive. Keep questioning the structures around you, keep looking for the invisible friction, and we'll catch you next time.